parameters which are present in the AC circuit. Okay. In case of AC circuit, there will be a resistance, inductance, and the capacitance. Okay, all these three parameters having the different characteristics. Based on that characteristics, which will behave its performance. Because of that reason, the analysis of this resistance, inductance, and the capacitance for the AC source of voltage, that is important. Here, first we can consider a pure resistance which is get connected to the voltage source. V is equal to Vm into sine of omega t. Whenever you are applied V equal to Vm into sine of omega t, which will causes a current I, that is also instantaneous in nature. So that V is equal to Vm into sine of omega t, but I is equal to Vm divided by R into sine of omega t. It means that the current and voltages both are in phase. It means that minimum values and the maximum values are to be occurred at the same instant. That is what in phase performance. Okay, that is with respect to the what? Pure resistance. But whenever you are applying with respect to this one, the input voltage V is equal to Vm into sine of omega t, then there will be necessity to make the evaluation of the RMS value. Okay, that is Im is equal to Vm divided by R. I is equal to Im into sine of omega t. RMS value of the voltage is what? Vm by root 2. Okay, with respect to the current is what? Im by root 2. V is equal to what? I into R. This is the what? The whatever the voltage drop which it is occurred across the resistance R. That is the VR. This is what? The operation what which is taking place with respect to that of pure resistance. Then here we need to consider the power evaluation corresponds to that of the pure resistance. What is the power equation? The product of voltage and current. Okay, those voltage and products are what? Instantaneous values. That is small v and the small I. What is v? Vm equal to Vm into sine omega t. What is I? Im into sine omega t. Vm into Im sine square omega t. Okay, sine square omega t is what? 1 minus cos 2 omega t divided by 2. So that Vm into Im by 2, then Vm into Im by 2 into cos of 2 omega. Okay, this is the what? The equation to be get considered in case of pure resistance. Yes, in previous I have discussed voltage and current both are in phase. Okay, this is also be positive, this is also be positive. What I will get the power? Power is also be positive. Then current is negative, voltage is also be negative. Minus into minus is what? Plus. I will get again the positive power. It means that the power will be available for both positive half cycle as well as the negative half cycle. So that the whatever the instantaneous power is to be happened will having the two part. One is the constant part and one is the fluctuating part. But due to that scalar quantity, whatever the fluctuating quantity is there to be taken as 0 itself. So that Vm into Im divided by 2 plus 0. What is Vm? 2 will be taken as root 2, root 2. Vm by root 2, Im by root 2. What it is? This is the RMS value of voltage, then RMS value of current. isn't it? It means that power consumed by the pure resistance is equal to that of RMS value of voltage and the RMS value of the current. That is V into I. What is the unit for it? Watt. This is in case of pure resistance. Is this clear now? Anybody having any doubt? Okay, that explanation is present in my notes. You can go through once. Okay, then what happening here? Voltage, I will take V. Then current, I will take I. Both are in phase. What is the angle between the voltage and current? Pi equal to how much if it is in phase? Is my audio clear now? Anyone reply? Raise your hands. Is my audio clear? Then why you are not replying? If voltage and current are in phase, what is the phase angle?
0 degree.
That is 0. Okay, if it is a pure resistance, what is pi value? Voltage between voltage and current is 0. What is power factor? Cos pi. Okay, that is the cosine of the angle between voltage and current is itself is called as power factor. Okay, cos 0 value is how much?
1.
It is, got my point. Okay, this is the PF. In case of pure resistance, the power factor is equal to unity. But generally what happens with respect to the power equation in case of AC circuit? P is equal to VI into cos pi. Isn't it? In case of pure resistance, cos pi value is what? 1. If cos pi is 1, product of RMS value of the voltage and current, that can be derived here by the use of this equation. Understood now? Okay, this is with respect to the PPT. Then same thing will be available here. The resistance, sinusoidal voltage, then current and voltages are in phase. Okay, so that this is the sinusoidal waveform representation. Then instantaneous power. Okay, then whenever you are going to integrate with respect to the complete half of the cycle, then what you will get? EM into IM divided by 2. Okay, you can take E, you can take V, not a problem. Okay, E is also be voltage, V is also be voltage. So that EM divided by root 2 is what? RMS value of the voltage. IM divided by root 2 is what? The RMS value of the current. Okay, so that the power, whatever is to be present in the network for the pure resistance is always positive. That is the product of RMS value of the voltage and current. Is this clear now? Okay, this is what? Current equation, voltage equation, and the power waveform. You can practice this. This also they will ask in the examination. Next, with respect to the conductance. What is this conductance? It is the property of the conducting material by which opposes the flow of electricity through it. Means the whatever the conductance which is occurred will make effect on conductivity. That can be defined in terms of reciprocal of resistance. Is itself is called as conductance, which is to be represented by capital G, which is equal to 1 by R. The unit is mho. Okay, or which can also be measured in terms of Siemens. Okay, in first class I have discussed about this. G is the conductance, which it is measured in terms of mho. or Siemens. Okay, this is with respect to the what? Pure resistance. Okay, next with respect to the pure inductance. Okay, in case of pure inductance, what happens? Here, we are going to apply to the inductance voltage V is equal to Vm into sine of omega t. V is equal to Vm into sine of omega t will cause the current small I, that is the instantaneous current. But in case of pure inductance, whatever current is there will lag the voltage by an angle 90. Current will lags voltage by an angle 90. So that V is equal to Vm into sine of omega t. Okay, then which can be represented with respect to the Vm sine omega t is equal to L into di by dt. Then I want the change in current. Okay, that is what? Vm by L into sine of omega t into d theta. But the di is what? The change in current. So that I am going to integrate this equation on both sides. Integration of di is what? It is the I. Because constant is 1, which will remain with respect to that variable I. I is equal to Vm divided by L integration of sine omega t into dt. What is sine omega t integration? Minus of cos omega t divided by omega. So divided. So that Vm divided by omega L into minus cos of omega t. But cos theta, how we can write? In terms of sine of omega t minus pi by 2. Okay, because whatever the value you need to represent that negative parameter, so that omega t minus pi by 2 you are taking, because the negative value will come with respect to that of evaluation, the trigonometric conversion. I is equal to Vm divided by omega L into sine of omega t minus pi by 2. It means that current will lag the voltage by an angle 90 degree. What is Im? Vm by omega L. What is omega L? Omega equal to what? 2 pi f. Okay. What is this L? Inductance. 2 pi fl is what? Inductive reactance. XL. So that whatever the current is there, Im is equal to Vm divided by XL also. Okay, so that we'll get I is equal to Im into sine of omega t minus pi by 2. Okay, this is with respect to that of pure inductance, which is to be caused when we are going to apply V is equal to Vm into sine of omega t. Okay, that will be represented here. Here, current. Once that current is occurred, then that is, once voltage is occurred, then current will follow. That is what? Lagging. First appear with respect to the voltage, then current will be followed. That is what it is called as lagging. Leading means first current, then voltage, which will be happen in case of pure capacitance. Is this clear now? In case of pure inductance? Nobody is speaking. Whether you are listening or not, I also don't know. Okay, if you are listening, it's well and good. If you are not listening, then it's your problem. Okay, then I need to make the evaluation of the XL, that is omega L, which is equal to 2 pi FL. Then what is the F? Frequency of the supply. What is the L? Inductance. The inductance will be measured in terms of Henry. Frequency is measured in terms of Hertz. But we need to make the derivation with respect to that of the power which it is to be absorbed by the pure inductance is equal to 0. Because the inductance will not consume any power. Okay, so that I will refer my notes. Okay, what happens with respect to that inductance? What I discussed, whenever you are going to apply E is equal to Em into sine of omega t, or V is equal to Vm into sine of omega t, which will causes the current flow. Okay, that current flow is I is equal to Im into sine of omega t minus pi by 2. Okay, so that Im is equal to maximum voltage to that of inductive reactance XL is equal to omega L, which is equal to 2 pi FL. Okay, this itself is called as inductive reactance, which will opposes the change in current which it is to be caused by the what? Inductance. Okay, in this case what happens? Current will lag the voltage. Okay, that waveform will be represented here. I is equal to Im into sine of omega t. V is equal to Vm into sine of omega t. I is equal to Im into sine of omega t minus pi by 2. Then what happens? The instantaneous power I have to evaluate. Instantaneous power, which is to be consumed by the inductance, is given by P is equal to V into I or E into I, because I have taken E as a equation. So that Em into sine of omega t into Im into sine of omega t minus pi by 2. Im into that is a sine of omega t minus pi by 2 will be represented by what? Minus cos of omega t. Okay, sine into cos is the what? Sine 2 theta by 2. Here omega t is there. So that sine into cos 2 sine 2 omega t divided by 2. So that negative value will be present, minus Em into Im sine of 2 omega t. But what we want? We want the average power which is to be get consumed by the connected network. Okay, so that the average power to be get consumed by one complete cycle. Okay, which it is P is equal to 1 divided by 2 pi 0 to pi P with respect to the d omega t. 1 divided by 2 pi minus Em into Im by 2 into sine of 2 omega t with respect to that of d omega t. Okay, but we have to do integration with respect to the what? Only sine of 2 omega t. Remaining all are what? These are the constant. Minus Em Im divided by 4 pi. Okay, integration of sine theta is what? Cos theta by 2. Okay, that is because 2 theta is there, cos 2 omega t divided by 2, because differentiation with respect to the d omega t. So that if dt means omega also you have to taken into denominator section. What happens? The integration of this value becomes minus cos 4 pi by 2 plus cos 0 by 2, because I am going to substitute this now in terms of t, that is omega t. Then I will get the value of minus cos 4 pi by 2 plus cos 0 by 2. What is cos 4 pi? It is 1. Minus 1 by 2 plus 1 by 2. What happens? Average power consumed by the pure inductance is equal to 0. All of you listening me now, raise your hand. 7, 15, 21, 24, 26, 29. Okay, thank you. Drop your hands. Okay, this derivation is also important. They will ask inductance or capacitance. Fixed question. The average power consumed by pure inductance and pure capacitance. Okay, this derivation you can follow up. Got my point? By considering the equation Em into sine omega t, then Im into sine of omega t minus pi by 2. Then later you will derive that equal to 0. Okay, once you go through these notes, even though if you are not getting, then you can ask this mathematical derivation. This is most important. Don't write directly like this. In my PPT is there. Like this you don't write. You won't get marks for this. You have to derive like this, all the steps. Then only you will get the marks. If not, you won't. Okay, then what is inductive reactance? Inductive reactance will be represented by XL. the property of the inductance by virtue of which opposes the flow of current through it, or else the change in current which is to be happened in the inductance. Okay, that itself is called as inductive reactance. XL is equal to omega L, which is equal to 2 pi f L. 2 pi f is what? It is the omega, angular displacement, radian per second unit. Omega unit is radian per second. Inductance unit is Henry. Remember that. Okay, whatever the power is to be happening with respect to that value. Okay, here this is negative, this is positive, negative, positive. Both will get cancelled. These together will get cancelled. So that the average power which is to be consumed by the pure inductance is equal to 0 because of 90-degree displacement by the current and voltage. Got my point? Is this clear?